So today's the day that we put some power on this thing. So yeah, the idea is basically to get the thing powered up, to get it moving sort of like according to the commands that we put in accurately, and yeah, without sort of tearing itself apart. So we're going to be a little bit conservative and gradually build up from, you know, sort of getting some safe things done first, so that things that we do later, hopefully if they don't quite work out, don't result in the thing you know, pushing axis all over the place. So to get this thing up and running and sort of do the basic setup that we're going to do now, we only really need two things. The first thing we've already got, we covered it, or I covered it in the video about configuring Marlin, and that is the Arduino IDE. So you need a working version of Arduino IDE that is connecting to the Arduino board, which we've already done. So that's a good sign. I mean, at least on the PC, where I talk about the Mac. And of course, the other thing, like I just mentioned, is having Pronterface. And again, that is available in the, and that's the version I'm using on the PC at least, is the Pronterface that comes with the Prusa i3 drivers download. I will be linking all of that on the webpage that is associated with this video. Of course, it's all free, so you can download that and install it. And if you can get it running on an old 10.7.5 Lion Mac, let me know how you did it. So the only other thing that I haven't really covered up to this point that you will need, obviously, is some power to the printer. I'm going to be using the a sort of benchtop power supply right now, anyway, to do this bit, because I can control the voltage and I control the amperage and stuff like that. And yeah, it's just easier. To do this, that will be good enough. I won't be running the heated bed, so that kind of removes one of the variables out of the equation. I don't have to worry about the heated bed. It literally just is not. There is no 12 volt V2 connection into the ramps board, and all that does is provide power to the heated bed. It's just not connected at all, so there's no chance of that getting warm. Right, so, well, let's crack on, shall we? Right, so the first thing we're going to do is, my hand is just, with it powered off obviously, is just move all of the axis sort of roughly into the center. The only reason I'm doing this is just to give us a flying chance of hitting the power button if things start going AWOL when we plug it in. So yeah, that one's sort of in the middle, that one's sort of in the middle, and that one's sort of in the middle. So yeah, that's the only reason we're doing that. The other thing to make sure is that for now, make sure that your Z probe, the proximity sensor, I really can't decide what to call this thing. I'm going to call it proximity sensor because that's what it is. Make sure it's sort of well down below the nozzle for now. We'll get around to adjusting that later, but if it's well below it, then you know, it's going to kick in before mashing into the, well, before it mashes the extruder and the hot end into the bed, hopefully. Okay, so time to hit the power button. Everything's wired up, powered up. I'm going to use my, as I said, the bench power supply. So let's hit the power button and be kind of ready to unhit the power button if it starts whirring around and doing all sorts of weird things. Well, it's kicked into life. Nothing's smoking and nothing's moving, more importantly, so that's good. Well, hopefully that's good. Yep, the hot end fan is spinning around. So we have a fairly happy situation here. The LCD is doing some stuff, and yeah, we'll get around to that in a minute. So what we want to do now is to plug in the USB. Obviously, I've already plugged it into the back of the ramps, and then plug it into the laptop. Right, so I've opened up Pronterface here from the Prusa drivers zip folder you can download from their website. This is what it looks like. Basically, we have already connected to the Arduino when we uploaded the basic configuration and Marlin into it. So we know that this particular PC can connect to it, and we know that it was on COM4. By default, Marlin is set to 250,000 baud rate, so make sure that's set to 250,000. Make sure you're not uploading anything in Arduino IDE, because you can only have one connected at a time. And let's hit the connect button and see what happens. There we go. So we get a whole bunch of stuff on the right hand side here. All connections, that's showing good. This is now all sort of active, so that's all good. So far the printer's not doing anything weird. We're getting temperatures reported here. The heater is being reported at 16 degrees and the bed at 14 degrees. which is probably about right. We're going to do all of this setup in a few stages, and the first stage is to set up the limit switches so that the printer knows when it's hitting the end of its travel and doesn't like keep smashing into one of the sides or something of the printer and yeah, making havoc with the stepper motor. So let's have a look at getting the limit switches set up. So the first thing we're going to do is go down to the, on the right hand side here, we can see and view all of the activity that's going on, the communication between the printer and Pronterface, and down at the bottom here we have a line that we can enter G-code in. So what we'll do to get the status of the end stops is put in M119, and you can see that as it happens at the moment, X, Y and Z are all triggered, which is not correct because we have moved all of the axes into the center, so they are not pushing up against any of the switches, which means that they are all reversed. What we'll do to test it out is simply put our finger on one of the limit switches, and as you can see, yep, it's working. The little red light comes on to say it's triggered. And then if we go back to Pronterface, and we don't really need to do anything else here, if we just press down into that box down there with the M119 in, click enter, and you can see that X, which actually is the right limit switch because that's the X limit that I've got my finger on, is now saying open, which is exactly the opposite of what we wanted. We'll do the same thing with the Y switch and click on return to do 119 again, and that is now open. And we shall get something metallic and hold it up against the Z-axis probe and do it again, and as you can see, that is now open. So we can tell from this the X, Y and Z are all exactly the other way round, or the wrong way round. So we'll go into the configuration H file in the Arduino IDE and reverse all of those. We're going to need to find the section in here that deals with the end stops. There we are, end stop settings. Not that, not that, not that, not that. No, pull-ups all seem to be okay. Right, here we are. Here's the inverting. So as you can see, we've got settings for all of the X, Y and Z min max. Well, we're only using min anyway, so they're the only ones we need to worry about. And currently they are inverting false. Now we want to reverse the logic of them, so we shall change them to true, like so. X, Y and Z, and because we are changing Z, we also need to change the probe end stop. We also probably need to look at the extruder motor, which may also run in a different direction, but we'll do that at the end. We'll just work on the movement axes for now. So once we've done that, we can save it and we can compile and upload. One thing to remember when you're running both Pronterface and the Arduino IDE is that only one of them can be connected to the Arduino at the same time. And we were in Pronterface here and it is connected, and that will cause an error once it gets to trying to upload in the Arduino IDE. So we need to disconnect before it will go ahead. It's okay at the moment because it's just compiling, but once it's finished compiling, it will automatically try and upload it to the Arduino, and if Pronterface is connected already, it will error. So it's going to take a little while to compile this, and yeah, I'll skip that and get back to you once it's done and uploaded. Right, so it's now getting to the end. It's verifying that the data it's done. There it goes, it's done. So it's finished uploading. Right, let's now, we don't need to disconnect from the Arduino IDE. It automatically disconnects once it's finished uploading. So let's go back to Pronterface and hit connect, and there it goes and connects again. Let's issue that M119 command, and now we can see that all of them are open. So we repeat the exercise of putting our fingers on the limit switches, and there we go, X is now triggered. Let's push the Y one down, Y is now triggered. Let's hold a bit of metal up against the Z probe, and Z is now triggered. So that is a happy situation. Right, so step 2. Let's see if the motors move and that they move in the right direction. So very timidly, what we're going to do is we're going to click with these controls here, we can move the axis around the bed. Now basically, very quickly, We can home particular axis at the same time, which we definitely don't want to do at the moment. And by clicking in these various segments here, we can move each axis, this one being the Y, this one over here being the Z, and this one being the X axis. And you can see that that segment moves at 0.1 mil, that segment moves at 1, 10 and 100 mil, and it's the same for all of these sections around here. The Z axis, there's no 100, you can move it 0.1, 1 or 10 mil. So what we'll do is very timidly, we will pick an axis and we'll try with the X axis, and we will click 0.1 and be ready to turn things off if it doesn't move just a little bit. If it suddenly starts moving a whole lot, hit the power button. So let's do that. And yeah, it did indeed move a very small amount, which is okay. So we'll try a bigger amount. Let's try 1 mil. Yep, that's moving about 1 mil, I would say. And 10 mil. Looking good. The only thing is, it's moving in the opposite direction. When we press the X button, the X axis should move from left to right, looking at the front of the printer. So that motor needs reversing. So let's try Y. Again, we're going to start off with a little baby step. And I can see already that I was also running in the wrong direction. Let's try a 10 mil move. Yeah, moving fine, but in the wrong direction. So let's have a look at Z. Okay, it's not going ballistic. Let's try 10 mil. Alright, so we clicked 10 mil Z axis up, and it moved about 10 mil down. We'll need to measure exactly how far it moved, but it moved around about 10 mil down. So we need to reverse all of the motors. So let's disconnect from a Pronto phase so that we don't need to worry about that. Go back into the Arduino IDE and let's have a look for the sections where the motors are set up. Here we are. Invert the stepper direction. That's what we need to do, and I've even put a note here from when we did the config the other day. Need to check. So we will reverse all of the stepper directions by changing all of these falses to true. And whilst we are here, we'll also make sure that the axes stop moving when we move them manually when it reaches the limits that we haven't set up yet, but yeah, we need to do that anyway. Here it is here. I disabled them for some reason. I thought that might be a good idea, but actually I think it's probably better that they're enabled for the minute, just to stop us manually moving past any extremes of the bed. So let's uncomment these, which will enable them, so it will mean that we cannot move beyond 0 or whatever we define as the maximum movement of any axis. So I will save and I will upload and yeah, wait a couple of minutes. Right, so that's now finishing uploading and verifying. So once that is done, we can move back to Pronto face like so, and we shall connect. And keeping an eye on the printer there, let's move, and we can confidently move in 10-degree steps at the minute. Oh, actually maybe not on the Y. Okay, so let's move the X right or plus 10 mil, and hopefully, it moves from left to right, so that is now correct. Move back the other way. Let's move the Y-axis towards us. So we hit the 10, and there it is. It's now moving in the right direction and backwards. And let's test Z. So let's move Z up 10. There it goes. Let's move Z down 10. Happy days. Now what we need to do is to start setting up the bed extents, i.e. where we will allow printing to happen, because at the moment it's got some end stops, but we can't print all the way to the end stop, certainly not on the X-axis and probably not on the Y-axis either, and we need to tell it to stop before it hits the other ends of those extents, because there are no maximum end stops, so we need to tell it how far away from the beginning it can go before it stops and, you know, won't allow printing in that area. Okay, so the way that I'm going to do this is by using Pronterface to manually move the axis around so that I can get them where I can measure exactly the offsets that I need to be looking at. So I'll move the x-axis over to the left. We've hit the limits on here, so we're going to have to move it by hand. What we'll do is we'll turn the motors off, and that will allow us then to move the axis around by hand, and then I can measure the distances that we're looking for. Right, so I've moved the z-axis down by hand so that it's much closer to the bed. It will just make measuring things a bit easier. And I have moved the x-axis right over until it's hitting the limit switch. Now I don't know whether you can see this or not, but if I point with a pokey thing, that is the nozzle there, and as you can see, maybe it's a good 4 or 5 mil off to the left of the bed, so that obviously is no good. We can't print in that area. So what I'm going to do is I'm going to use some kind of measuring tool, and this one here will do fine. And I will measure how far over we need the x-axis to come before it's actually on the bed in an area where we can print. So I'm just going to stick the ruler down. I'm going to line it up roughly with the nozzle and look for a safe area. I'm calling it 7 mil, I'm going to say, is a nice safe area. So now if I move with Pronterface in the 1 mil, move the x-axis right 7, that actually is fine. That is now sitting over the bed nicely. So we have one of our extents, and that is the x minimum. So let's now look at the y minimum, which is pretty much the same situation. We will, in fact, for now, I'll leave it there. Switch the motors off again, and I'm going to push the the bed all the way back until it hits the limit switch. There, and we can see that we have a bit of an issue, or we will have a bit of an issue, and I need to move away from the microphone so you probably get a bit echoey. This here is going to hit that nut there, so we actually need to move the Y quite a long way forward before we can actually safely start printing, and I measure that to be 37 mil. So now if I jog Y negative 37, that's 3 times 10. 1, 2, 3, and then 7. 1, 2, 3, 4, 5, 6, 7. And yeah, that actually looks kind of okay. Let's see if we can put Z down a little bit. No, Z's at 0. But I can just about see that that's okay. That's going to clear that nut just about. That's going to maximize the size that I can use. So we have our limits. We don't need to do a Z limit because Z will always be 0 in our case, because we don't really have any obstructions. So we're going to have to go back into the Arduino IDE and set that up. And we want to look out in the configuration H file is the limits section, which should be around section homing. That looks good. Right, here we are. Now you'll see that I sort of set a default of -10 the other day, which actually is not that far away. We want -7. Now the reason we want -7, and yeah, the best way to look at it really, I think, in my head at least, is that we want to reduce the size of the print bed by 7 mil, because we need it to move over 7 mil. So basically we're saying, yeah, take 7 mil off the size of the bed. So we want 7 mil off there, and we want -37, which is what we measured to clear that nut, off of the Y. Now the other thing that we want to do is, before we do any auto homing, is we need to go and find the safe homing section. Here we go, homing. Right, as you can see, safe homing, I left it disabled. We want to enable it. Because we have things poking out of the heat bed, we need to make sure that before Z does its homing, i.e. moves up and then down very close to the bed, that it does that Z homing in a nice free space in the middle, or anywhere not at the sides, away from those nuts. So we will uncomment safe homing and save it and upload it, and I will be back once that's done and uploaded. Okay, so there it is, it's done uploading as it tells us. We'll move back to Pronterface and we shall connect again. Now what we're going to do is move the axis more back into the center. As Z's pretty low, I'm going to move that one up straight away. And do the same with the Z. And the same with the Y. Right, now let's try a home. I think we'll try them one at a time first. Let's try an X home by clicking this button here. There it goes. And it's on the limit switch, which is good. Let's try a Y home. Yep, that's on the limit switch. Let's before we do a Z, because that won't work very well, we shall move the Y-axis 100mm towards us. It's fine. Move the X-axis 100mm to the right, and then let's try homing Z. There it goes, it's moving down. Now, all being well, the probe will work and it won't mash into the aluminium bed. It's going down, you need to have faith. There it goes, it's sensed the bed, it's moving back up. It's going to move down much more slowly now, in fact at half speed. This is all configurable, I haven't changed this, it's default. Moves down at half speed. Senses the bed, and then it moves back out of the way. I think around about 10mm is what I set up the other day, or maybe it was default, I don't remember. So that having been done, I can be fairly confident that we can home all by clicking this button here. So it's going to do X first, then Y, and then because we've got safe homing on, it moves sort of more or less into the center, and it does Z. So we have homing, kind of happy. Now what we want to do is we want to see how our minimum extents are working out. So if we put in G0, and I don't think we need to do anything else, but I will, I'll just do X, Y, Z, it will move all three axes to the point where it thinks is the sort of offset 0 point, i.e. the printable area at 0, 0, 0. So let's hit enter. There it goes, it's moving all three at the same time. And that looks pretty spot on to me. You probably can't see it on the camera, but the in the X direction, the the nozzle is just over the bed where we wanted it, and it looks like the Y-axis is just about missing that nut, which is good. Z is, where is Z? Let's have a look. Let's do another M114. Z's at 0. Right. Okay. It looks to me that it is about 2mm off the deck, and that's exactly what we set the probe offset to, 2mm. So that's good. We'll actually set the fine tuning of the Z-axis in terms of the nozzle and the probe in a bit, but we've got some good homing. The next thing to do is to have a look at the maximum extents, i.e. how far it can move all the way to the left, how far it can move all the way back or forwards, depending on which way you look at it, and how far it can move up. Now we think that we're at 0, 0, 0 here, so I can use the jog to move it, and I will move it 100 over in the X direction. I will move it now steps of 10 until the nozzle is just about. Okay, we've hit a bit of a blocker there. That means that the it's limiting us to the extensor we put in, which was 190. So we'll need to disconnect from here and go back into Arduino IDE. Right, so we've set these to 190, 190, 190. Oh, sorry, 190, 190, 150, and it's obeying that. That's why it won't let us move any further over to the right currently. So what I will do is I will leave the minimum end stop enabled because we've set that up, and I will comment out the enabling of the max end stops. Save that, upload, and I'll be back once that's done. All right, okay, so that's done uploading. Right, let's skip back. There we are. Let's connect. Right, now from here on in, every time that you power up the machine, or every time I power up this machine actually, because I doubt you will, or upload it to it, it basically resets, obviously, when you power it, but every time you re-upload firmware, it resets, which means it has no idea where the axes are. So you're always going to have to do a home. So let's home all. Now what we want to do, hopefully we should be able to move the axis beyond what's set in the IDE, i.e. that 190, 190, 150. So let's move the x-axis over in steps of 10, and all being well it should let us go. Yep, it is. So we'll move this over until the nozzle is more or less sort of equidistant to the 7mm on the other side, and it's probably about there. Now we can do the M114 and see where it thinks it is. So it's saying that it's at 204. We'll round that up to 205. Let's just do one more mil. Do a 114 again. Right, 205. So our X max stop is going to be 205, which is good. Right, so let's move the X axis back over into the sort of center somewhere. And let's do the same for the Y. In fact, what we'll do first of all is we'll just home Y like that. And we will now move Y in our maximum direction that we can. And that is going to be so that it misses the nut at the back here. We've got the hot end, which is around here somewhere, needs to miss the back. So I'm just going to use the jog dials in Pronterface to find out where that is. Yeah, that's actually quite a decent space there. Let's see if we can get away with 157. Make sure that we're on 57 with an M114. Yep, that clears. So we'll call it 157 as our maximum. Once you've done that, your positioning is all to put, so we need to home everything, but we have the info that we need. So let's go back into the IDE. We can disconnect this, it's doing its thing. Right, so let's go back to the IDE, and at least we can set X and Y. So we're going to set X to, what did I say it was now? Oh yeah, 205. And Y to 157. Right. Yeah, I won't upload that for a second actually, because we can do the Z before we upload again. So let's go back to Pronterface, connect. So let's home again, and let's jog Z up. We'll have to do this a few times. We can only move Z maximum increments of 10. Keep pressing the button. Now on the Z we just need to be aware of something. That is that when you click home, Z is automatically going to move up a certain amount as defined in configuration H. So we need to allow for that before we set our X maximum. And let's just have a look to see what that is at the minute. Actually, while I'm trying to find that particular parameter in here, where are we? I'm going to speed up the Z axis. So at the moment we've got it for 200, 200. X and Y I'm kind of okay with. Z is slow, so I'm going to increase that to, let's try 8. So let me get back to finding what I'm looking for. Here it is. Z clearance deploy probe. Right, now in theory I don't think we really need any of this, but let's put 4mm in just to make sure it's out of the sensor area. We'll leave that for now. We don't need to deal with it for now, but what we do need to know is that we're going to have to leave 4mm extra from the top. So let's carry on going back up until we get sort of somewhere near the nuts bottoming out. As you can see, it's a little bit pissed off to one side at the moment, but we won't worry about that. In fact, what we'll do is we'll just turn the motors off for a second and manually level them out a little bit. Bolts holding them on are just touching the top. And then we'll move Z down 10 mil. And we'll move it back so it's pretty close, but not right at the top. There you go. Yeah, that is almost touching. So we need to allow 4 at least. So let's go down 4. And let's see where we are with an M114. So Z is saying 186. So really 186, if we want to be really close to the wind, is our Z end stop. So if we go back into the Arduino IDE, it's the Z Max Pods, and we're going to make that 186. We will now re-enable the maximum end stop stops, so it won't allow us to go past those because yeah, they should work. And we will save and we will upload, and once that's done we'll test it out. Right, okay, we've got a bit of a compile error here. Basically what it's saying is that it can't achieve the bed leveling that's currently configured because we haven't configured it. It's the default, but the default configuration can't be achieved because of our maximum end stops. So what we'll do is go into configuration H and let's find those parameters that are causing the problem. Here they are. I've added a comment to them so that we can get to these more easily, because we will need to address these shortly. But if we look at this, the back probe is saying that it wants to probe at 170, and yet we've set the maximum Y to whatever it was, 157, so it can't get there. So for the time being, what we'll do is we'll just change that to 130. The rest of those should be fine, so I shall save and upload again. Once again, I'll be back, albeit hopefully with no errors. Okay, so that's finished this time without any errors, thankfully. So let's hop back into a Pronterface, reconnect. There we go, and sadly we will need to home, and Z's all the way up there, so it's going to take a bit of time. As you can see, it's moving quite a bit quicker now. So any second now it's going to finish doing its homing. First thing we'll do is we'll cruise all the way right, and there you go. We can no longer, doesn't matter how much I click it, it has stopped exactly where we want. So let's move that back into the center. Let's move Y forward. There we go. We can't go any further there. Let's actually move X over so I can just double check that. Good. So let's move X back. Let's move Y back. Let's go up on Z. It'd be really nice to have a plus 100 on the Z. Of course, we could do it a G code, but well, yeah, where's the fun in that? Just keep mashing the button, and all being well, a minute we'll mash the button and it won't do anything. There you go. Now we should have our 4 mil of clearance, so that if we do home, it will be able to go up those 4 mil before homing. So it's going to do X first, Y, it'll go up on the Z slightly. It didn't. Anyway, good enough. That's good enough. That is our bed extents done. Okay, so now that all seems to be working alright, we'll move on to the bed leveling. So what we need to do for this one is we need to measure exactly the offset of the probe to the nozzle. The reason why is that the bed leveling is based on a position of the probe rather than the nozzle. So we need to get those offsets kind of about right. So I'm going to measure those a second quite simply with a ruler, and I measure them to be 23 mil on the X axis, so that's plus 23 on the X, and 9 mil on the Y. For the time being we will set the Z to 2 mil just to keep things safe. So what we'll do is we'll go back into the IDE and I shall find the relevant section. Here it is here, and there is already some values in there that I put in the other day from Tom's video. Now, yeah, I don't think this is too critical, but anyway, seeing as I measured it, I'm saying it's 23 and 9. And we're going to say 2 for the time being for the Z. And then whilst we're here, we shall change the bed position. So let's search for probe underscore bed. Oops, we won't find BD bed. Right, here we go. So basically what this is where we want the most left point and the most right point and the most front and the most rear point. It will interpolate 4, as we've set up 4 for each in between. So we want to set first of all the leftmost point that we want it to probe, and that is the position of the probe sensor. So if we say 25 for the left, and let's say 180 for the right, because that will put our probe, yeah, about 25, well, yeah, almost exactly 25 actually from the right side of the bed and 25 from the left side of the bed. And then for the front, and these figures are relative to our G-code 0. I don't really know the proper term for that, but not the limit switches, but the zeros that we put in for our print area effectively. So really we want it to print as far to the front as possible because we're already quite set back. Seeing as we have a 9mm offset, we shall set that to 9, which means the nozzle should be at about 0, which is as far forward as we can get. Then at the back we want it to be, well, something around about, where were we, 154 I think we said was our maximum Y. So let's set this to 154 minus 9 is 145, and that should do it. So we'll save. I shall upload and get back once that is done. Okay, so that's done uploading. Let's go back to Pronterface. Let's connect. La-di-da-di-da. Sadly, we will have to home again because we've disconnected and it doesn't know where it is. By the way, I keep getting that SD init fail down there in the console. I don't even know what that means yet, but I'm not that bothered either. It might just mean there's no SD card in it, because there isn't. I don't know. Right, so it's homed. Now let's try a mesh bed level. And to do that, we go down to the console here and we put in a G29. There it goes. As you can see, well, no, you probably can't see, but you'll have to take my word for it. The sensor, the probe, is now probing those points that we specified in the configuration H file, and it's sort of interpolating the ones in between. So it did the furthest one first, and now because we've defined 4 in each axis, the next one should be about 25mm from the side. Yep, that looks pretty good. And the position front to back is good. The ones in the middle are a bit dull because, well, we know where they're going to be. We can guess that from the other ones it just did. Right, so it's moving on to the last point now, which could be a bit further over to the right, but to be honest with you, it's good enough for me. Once it's finished there we go. So we now have our grid measurements. The general trend is that the center is higher than the edges. So that means that I have over my frame, my idea to pull the sides down and prop the front up has been a little bit over successful, which probably just means that I've tightened down those nuts too much. In CNC mill terms, they're horrendous, and we basically just give up and go home right now. But for this, I don't know, half a mil, I don't know, you tell me. Anyway, we'll call the bed leveling done. So the next thing that we need to do is to set up the Z probe properly. Yeah, and to do that, we're going to need to do a little bit of preparation. First thing that we need to do is now time to move the probe into its rightful position, which is around about 1 millimeter above the very tip of the nozzle. So I'm going to go ahead and do that now. Right, yeah, it's a mil, thereabouts. Couldn't tell you exactly how much, but it's definitely just slightly above the nozzle. The important thing really is that it is above the nozzle and that it isn't more than the distance away from its proximity range above the nozzle. So you've got maybe 2 mil to play with. So yeah, 1 mil should be comfortable. You can sort of test it out a little bit by putting a ruler up against the nozzle, keep it flat, and make sure that the Z axis limit is activated by doing an M119 in the console here. So yeah, the other thing that we need to do is to go into the IDE a minute, and we need to disable the limit that stops us from going below 0, because we're going to need to do that in a second. So we find that in here, right there it is. We can leave the Mac software end stops enabled, but we will comment out the min, because otherwise we won't be able to jog below what it thinks is currently 0. And that is what we now need to gradually adjust down. So I'll need to save that and upload it. Right, okay, so that's uploaded all right. Let's go back to Pronterface and connect. What we shall do is, let's just make sure that we're at 0. We are. Now, because we disabled the minimum limit to allow us to go below 0, because if we have a look where we are right now, we are at 0. Now normally we wouldn't be able to go lower than that, that's why we disabled it. I'm not quite sure if there is a logical reason to it, but sometimes even when you disable that in the configuration, this thing here, where are we? Even when you disable that like we have done, sometimes you still can't go below 0. And the only way I've really found of making it kicking in is by changing one of these and recompiling, re-uploading, going back in, changing it back to whatever it was, recompiling, re-uploading. I don't know if there's a logical reason for it. In any case, we need to be slightly careful now, because we can bash the old nozzle right into the heat bed. So what we're going to do is get our piece of paper, slide it over onto there like that. We will be about 1 mil off the deck, so we can use the jogger here to go down 1 mil. Did I say 1 mil? We're 2 mil off the deck. Use the jogger to go down 1. There we go. Now we need to be slightly careful about where we go any further, because we don't want to mash this into the bed completely. So let's just do another M114. We can see we're at -1, so that's good. Now if we do a 0.1 decrease whilst moving this bit of paper around until it binds. Now ideally you want to do less than 0.1, because that's a little bit too much of a movement. But aside of using the LCD, which I'm ignoring I've got for a minute, I can't find a G code that will allow us to move in smaller increments than 0.1 when we're below 0. Anyway, it's not terrible. We're only going to be going into the paper really. So let's just go down 0.1 at a time until this binds, and then as soon as it binds we'll go back up, just to not put any load on the stepper. That's getting slightly tight there, so the next one will probably lock it up. Yeah, there we go. So let's go up 0.1. So that's about right. So what we'll do is we'll do the M114 again, and we can see we're at -2.20, and yeah, I'm kind of more or less happy with the tightness on that. That's okay. The actual Z offset is -2.2 from where we've got it set currently here. So currently it's set to 2. So if we put it at 0, let's say, that would be then 0.2. So if we set it to minus 0.20, that should give us what we're looking for. So let's save that and upload it, and I'll, as always, come back once it's uploaded. Okay, so that's now uploaded. Let's go back to Pronterface and connect again. Let's home everything. Let's do the M114, and we're at 10.2. So let's stick the old bit of paper underneath and go to G0 on the Z and get ready with the power button just in case something goes horribly wrong. And now the paper is, well, it's just a little bit, it's just touching, which is probably alright, to be honest. Let's do an M114. We're at 0, and is it touching? Just barely. I think we could go a tad more. If you want to be a perfectionist about it, you can iterate backwards and forwards by going into here, and let's do 0.22 and upload that, and I will come back once that's done and we'll try it again. Don't forget, disconnect Pronterface. Okay, so that's done uploading. Let's go back to Pronterface, connect again, home again, move the bit of paper out of the way, put the bit of paper underneath and do a G0Z. And there we go, that's exactly right. I can just feel that now dragging underneath. That is, I would say, exactly the thickness of a piece of paper above the bed. So I need to get that Z out of there because it's creeping me out when it's so close. So I'm going to jog it up a bit. Right, so that we can get rid of our piece of paper now. I think, as far as I can tell, is all of the axis movements done. So let's now deal with the extruder. Right, so the first thing I'm going to do is check the direction of the extruder, and we can do that from Pronterface. Let's increase the speed to, let's say, 500, because we're not actually going to be putting any filament through it. And let's just extrude 20 mil, should be good enough. Then I'm just going to stick my finger in the side here and put it onto the, what do you call it? The hob gear. Yeah, don't get your finger stuck and jammed and twisted in there, but you shouldn't do. Hit the old extrude button and see which way the motor turns. Ah, it doesn't turn any which way because cold extrusion is prevented. So we need to go into the IDE. Let's disconnect from Pronterface. And let's find the cold extrusion. Let's see if cold gets us somewhere. Yep, there it is. So let's disable this for a second. Disable both of those. Upload it. And I'll come back when that's done. Okay, so we're all done compiling. Let's go back and connect in Pronterface. We've still got our settings down here, so I'm going to put my little finger in there again and hit the old extrude button. And I can feel that. And from the front it should be turning clockwise, and it is. And if I reverse, it should be going anti-clockwise. Oh, I tried to grab my finger. So that's good. Direction is good. Right, now we need to have a look at the feed rate. Before we can do that, we're going to need to heat it up and get some filament in there. So I have a bit of filament, and I've chosen obviously PLA to begin with. Let's not make things more difficult than they need to be. I've also chosen its, what is it, Filamentum Pearl Red, I think. I chose that because I thought it would be, firstly, quite good on the visibility of seeing the quality of the print and any issues and stuff like that, and secondly, it ain't grey. I'm more likely to use it in the future. So what we're going to do is, first of all, in Pronterface is select the right temperature, and 210 is fine for this PLA, and hit the set button, and we should see, and here, yep, we got a bit more current going through now. That's 3.5 amps nearly, and the hot end temperature thermistor seems to be working. It's heating up quite nicely. You can get a bigger picture of that. There we go. So once that once that reaches 210, in fact, I can stick the filament in now, really. So let's pokey this in here. Pull the adjuster out, try and get it down through the hole. There we go. Yeah, that's started. That's good enough. Right, now this is going to get a bit messy, so we're going to need to put something underneath to catch the filament that's coming out. So where are we? We're up to 176. So I can see the PIDs doing their job because the amperage is bouncing about. So we've reached 209 degrees, so that looks alright. Let's reduce that back down to 50 for now. And let's we'll just do it in sections of 20. I can feel the filament coming through or being pulled through. Let's do another 20. And there it is. Okay, so we are extruding. Right, now we need to do some calibration of the rates on the stepper. Put that to 100. And what I'm going to do is, right where the filament goes in, I'm going to make a mark with a pen that I can see, and then with some measuring device I'm going to measure out 50. and use the vernier calipers. Not very conveniently positioned. Let's move Z down a bit. Might be able to get my calipers in here now. Oh yeah, that's a bit better. So set it on the top and mark the 50mm point, and for good measure I'm going to mark a 55mm point as well. Right, that'll do. So let's set the extrusion amount to 50 and extrude, and let's see where we get in relation to those marks. Well, it's just gone past the 50 mark. It's got about just below the 55, so I'm going to mark that point on here and reverse out. Okay, let's come back to the original mark. So let's measure how much over that was. About 3.5mm too far. Right, we're going to need the calculator on the scene here. 3.5 divided by 50 is 0.07. So if we multiply our original feed rate, so I set it to 150. So times by 150 is 10.5. So if we take 10.5 off of that, let's call it 11. So let's take that down to 139. Save and upload that, and I'll be back. Right, that's all done. So let's go and connect back up in Pronterface. Let's extrude through, go past our original marks at least. Let's go to 60 should do it. Let's set the heat bed. Disconnecting seems to have shut it off, so we now need to wait again. That should do. Right, extrude. Yep, that's done. Right, let's mark out 50 and 55 again. Well, let's mark the entry point first. There. Now let's measure out 50mm. And then we'll go to 55 again and mark 55. Yep, that'll do. So let's set this to extrude 50 out and see where we end up. Pretty much bang on. That is spot on. So yeah, that should conclude. We've got all of the axis moving, and the extruder sort of seems to be working relatively accurately. So I think that sort of covers the setup. I'm going to spend a little bit of time, not right now, but tomorrow, going through the configuration H file and just making sure that any of the safety type settings I had to disable, like some of the limits and stuff like that, are all put back. Everything's correct. I'll probably increase slightly some of the axis feed rates. Certainly the Z axis can probably move a bit quicker in some of its movements, and probably reduce some of the lifts that it does, or at least the height of the lifts that it does, which seem unnecessary in this case. But yeah, only minor stuff. I think the majority of the big stuff is done. I will probably won't do it on a video, but I will put a little post on my website about any additional changes and the final configuration H file that I'm going to use for the first print. You might be wondering why I didn't use the LCD that I have, which probably would have made life a little bit easier. Certainly doing the Z probe, you can do some nice fine adjustments on there if you can see it. Well, I couldn't see it. Yeah, it gets all garbled after about a minute. It starts out fine. I don't think it's a compatibility issue because, well, yeah, it's fine for a while. So obviously it's probably noise coming in through the steppers and, you know, the power off the board and stuff like that. So it's going to need a little bit of isolation or maybe some shielded cables. But I think we got it covered. A little bit of tidy up in configuration H, a couple of wires for the heat bed, and we should be ready to print.